Today we're going to continue our look at continuous random variable questions that you might find in exams, and we're going to be looking at two of the more common questions that they ask, which is the expected value of a continuous random variable and the variance. Now we're going to look at these two formulae. They look horrific, but actually they really aren't. So let's have a look. For a continuous random variable x with probability density function f of x, the expected value of x, otherwise known as mu, the mean, is equal to the integral between minus infinity and infinity of x times f of x dx. That's the expected value. The variance, which is also the standard deviation squared, is the integral between minus infinity and infinity of x squared times our probability density function dx minus this, which the astute will probably notice is identical to that. So in actual fact, that is the expected value of x squared, and the variance is often written as expected value of x squared minus expected value of x squared, i.e. the mean of the squares minus the square of the mean. So inevitably what happens on these questions, they ask you to find the expected value and then the variance, and you use the answer that you found for expected variance, so you don't actually need to do the second integral again. So what we're going to do is we're going to do two questions, the first one of which is very standard, and the second one is a little bit more tricky and more involved. So let's go. Okay, so here's the first question here. Give you a second if you want to try and have a go. Okay, so a continuous random variable x has probability density function thus. If x is between 0 and 10, then it's x over 50, and otherwise it is 0, and they ask us to find the expected value and the variance. Okay, so let's go. So we're going to use our formula. The expected value of x is the integral between minus infinity and infinity of x times f of x dx. Now, in actual fact, we don't need to integrate between infinity and minus infinity because it's 0 outside of the range 0 to 10. So in this particular example, we only need to integrate between 0 and 10. X times, here is f of x, x over 50 dx. And that equals the integral between 0 and 10 of x squared over 50 dx, which equals x cubed over 150 between 10 and 0, which is 1000 over 150, which is 20 over 3. So our expected value of x, e of x, or alternatively the mean, is equal to 20 over 3. The second bit, the variance of x, we're going to use this in a second. So the variance of x, we're going to use our formula, e of x squared minus e of x squared, which is the same for discrete random variables as well. We discussed that in the previous video. Okay, so that equals the integral between infinity and minus infinity, and I will write the infinity and minus infinity, even though in actual fact it's going to convert to between 0 and 10. X squared this time, f of x dx, minus e of x squared, which we have already established is 20 over 3 squared. Okay, so that, as we just said, becomes the integral only between 0 and 10 because it is 0 outside of that range. So integral between 0 and 10 of x squared times by x over 50 dx minus 400 over 9, which equals x to the 4 over 200 between 10 and 0 minus 400 over 9, which is 10,000 over 200 minus 400 over 9, which is 50 minus 400 over 9, which equals 50 over 9. So therefore our variance is equal to 50 over 9, and therefore, even though they don't ask it, our standard deviation, which is equal to the square root of the variance, equals 5 root 2 over 3. Now I know they don't ask that, but anyway, they could have asked it. There's your standard deviation. Okay, this is a very standard question, no tricks in it. The second one is more like one that you might see in a higher level college entrance exam or higher school advanced maths. So basically, I'll give you a second, just have a look at that if you want. Okay, so we have a continuous random variable x probability density function here. Okay, so now this is a little bit more complicated. It's defined as 2x over 15 for x between 0 and k, 1 minus x over 5 for x between k and 5, otherwise 0. Now the first thing we have to do is we have to find k, and we've already done examples of how to do this in previous videos in the podcast, but anyway, let's go. And then we need to find the expected and the variance. So what we're going to do first of all is we have to remember that the integral between infinity and minus infinity of our probability density function is equal to 1 always. And we did do some questions on that in the previous video in this podcast. And so therefore, we're going to do this a little bit piecemeal here, because this is the function between x equals 0 and k, and this is the function between k and 5. Let's try and keep it on the thing. So that means that to do the integral, we will do the integral between 0 and k of 2x over 15 dx, add the integral between k and 5 of 1 minus x over 5 dx equals 1. So that's basically this bit here integrating between 0 and k, and this bit here integrating between k and 5. We've got one unknown here, which is k, which is what we've got to find. So that basically equals x squared over 15 between k and 0, add x minus x squared over 10 between k and 5 equals 1. Okay, so that gives us k squared over 15, add 5 minus 25 over 10 minus k squared over 10 equals 1. Let's multiply the whole lot by 30, make it a little bit easier. 2k squared, add 75 minus 30k, add 3k squared equals 30, i.e. 5k squared minus 30k add 45 is 0, i.e. divided by 5, k squared minus 6k add 9 equals 0. Now, unusually, this one actually comes out, factorizes to be a square like this. So therefore, we have k equals 3. And so therefore, on our probability density function, we now know this must be 3. It can't be anything else, because if it was anything else, then the integral of our probability density function wouldn't equal 1. Now, normally, you do get two answers. One of the answers will be within the range 0 to 5, and the other answer for k will be outside of that range, and you have to discard the second answer as being outside of the range. But in this case, there isn't two answers, there's only one, so we have k equals 3. Okay, so that's nice and easy. Right, so basically now we can go ahead and work out the expected value of x, which is equal to the integral between minus infinity and infinity of x times f of x dx. Okay, and again, we have to do this piecemeal. So we have to integrate this part of the probability density function between 0 and 3, and this part of the probability density function between 3 and 5. Okay, so that basically equals, let's give ourselves a bit of space here, the integral between 0 and 3 of x times 2x over 15. That's basically what the value of that's the probability density function between 0 and 3. Add the integral between 3 and 5 of x times 1 minus x over 5, which is our probability density function between 3 and 5. Okay, now it's just a matter of doing this. That's 2x cubed over 45 between 0 and 3. Add x squared over 2 minus x cubed over 15 between 5 and 3. Actually, as a general note, you will find that generally speaking, the integrals aren't overly hard for working out the expected value and the variance. They're more interested in making sure you understand how to do them. So that equals 6 over 5, add 25 over 2 minus 125 over 15 minus 9 over 2 minus 27 over 15. Just got a little bit of jiggery pokery here, equals 6 over 5, add 8 minus 98 over 15, which equals 40 over 15, which equals 8 over 3. So basically our expected value of x, which equals our mean, is 8 over 3. And now what we can do is we find the variance. Okay, so let's go on the next page here. So we carry on. So we need to find the variance of x. Remember, that is equal to the mean of the squares minus the square of the mean, and we already have the mean as 8/3, and so therefore this equals the integral between infinity and minus infinity of x squared, this time fx dx, minus 8/3 squared, which is what we just calculated. Again, we're going to split this into two, exactly the same as we did for the expected value. That equals the integral between 0 and 3 of x squared times 2x/15 dx, add the integral between 3 and 5 of x squared 1 minus x/5 dx minus 64/9, which is just the expected value squared, and that equals 2/15 x to the 4/4. Again, the integral is not the difficult part of this. Add x cubed over 3 minus x to the 4. Having said it's not difficult, it's very important, obviously, that you don't make a mistake, otherwise you just lose needless marks. So that equals 54/20. Add 125/3 minus 125/4 minus 9 minus 81/20 minus our e of x squared, 64/9. Just got a little bit of jiggery pokery here. Hang on, that's 135/20. 311/9. This is a little bit messy, that one. 125 minus 9, which equals, let's stick the whole lot over 18. 622 minus 441 minus 162 over 18, which equals 19/18. So that is our variance of x, or the standard deviation squared. And I know they haven't asked what the standard deviation is, but therefore the standard deviation is equal to the square root of 19/18, even though they didn't ask that. Okay, so I hope you have found this useful. In the next video, we will be looking at, they often ask, how do you find the median and the mode of a continuous random variable? Of course, we've already done the mean, which is the expected value, and we'll do that in the next video. Okay, well, I hope you found this useful. If you have, please press the little thumbs up button and subscribe to the Gresty Academy YouTube channel. And look out for more videos in the Crash Course to Continuous Random Variables podcast. Okay, thank you.